All right, children, so this is going to be your Unit 2, Day 7 video. We're going to be talking about the trig ratios, sine, cosine, and tangent. Here's a little glimpse of your do now. Don't really need to worry about that right now. Anyway, here's your EQs. What is the sine trig ratio? What are irrational denominators and how do we fix them? What is the cosine and tangent ratios? And what do we use those three trig ratios for? And last thing we're going to learn is a little acronym to help us remember everything. What does SOHCAHTOA mean? Right, so let's start with the first trig ratio, the sine ratio. So first, here's some examples. So we're given an angle and it's 45 degrees, and we're given this side here, and we want to find this missing hypotenuse, right? Well, we know that this is obviously going to be a 1 to 1 to square root of 2 right triangle. Okay, so what we have is a ratio of 1 to square root of 2, right? So we can go ahead and say that. So our ratio to opposite leg over the hypotenuse is 1 is to square root of 2, as 16 is to C that we're still trying to find. So 16 is to C, our missing hypotenuse. And of course, we would solve this just like any other proportion, right? So we get C, because that's 1 times C, is equal to 16 times the square root of 2, which makes absolute sense, right? Because if this is a 1 to 1 to square root of 2 right triangle, this missing guy would be 16. Obviously, this guy is 16, and then our hypotenuse would be the same length as the legs times the square root of 2. So let's try it again. Okay, and again, the ratio that I did there was opposite leg to hypotenuse. Let me go ahead and highlight that for you here. Right, so again, we see another example. So we're given this 30-degree angle. We don't know this opposite leg. Right, this leg is opposite of the angle we're using, and we're given the hypotenuse. Okay, so if this angle is 30, if this angle here is 30, right, then this guy must be 60, and that means that this is a 1 square root of 3 to 2 right triangle. And again, we're looking at short leg or opposite leg, this guy, to hypotenuse. Okay, so leg to our hypotenuse. So that would be 1 to 2, right, so this would be y to 10. So 1 is to 2 as y is to 10. Okay, so that's short leg is to hypotenuse. I guess I don't need to write it. I can't spell right now. It's early in the morning. Anyway, so we have short leg is to hypotenuse as short leg is to hypotenuse. Same thing, we're just going to cross multiply like any other proportion. 10 times 1 is 10, 2 times y is 2y, divide by 2 on both sides, and we get that y, our missing side, is equal to 5. And again, that makes perfect sense if this is a 1 square root of 3 to 2 or a 30, 60, 90, right? You have a ratio of 1 to 2 to square root of 3, so that means this guy would obviously be 5 square root of 3. Okay, so let's continue. Let me erase and give myself some room here. So we are given, I erased some things I didn't mean to erase. We're given an angle again. We're given the 60-degree angle, right? And we're given the opposite leg, and we're trying to find the hypotenuse. So again, this is the same kind of triangle as in the previous example, except, so it's 1 square root of 3 to 2, right? Except we're given the long leg, and we're trying to find the hypotenuse. So we have a ratio of square root of 3 is to 2 as 10 square root of 3 is to our missing hypotenuse. Same idea, cross multiply. So we're going to get square root of 3 times w is equal to 20 times the square root of 3. And we're going to divide by the square root of 3 on both sides, and we get w is simply 20. Okay, so what were we doing there? Well, again, we were doing the sine ratio. Sine is opposite leg over hypotenuse. Okay, that is the sine ratio. And all it's really saying, if we're going to use it as an operator, as a function. So here, for example, if we're trying to calculate, let's say, the sine of this angle here, the sine of the 45 degree. Well, that's equal to opposite, right? This is the opposite leg over hypotenuse. So opposite leg over hypotenuse. So the sine of 45 degrees is 1 over the square root of 2. However, this is bad, okay? Why is this bad, you may be wondering? You cannot have, so the square root of 2, if you throw that in the calculator, it's approximately 1.414, on and on and on and on and on. It's on and on and on and on and on because this decimal is called irrational. Okay, it's an irrational number. It cannot be written as a fraction, right? So, that said, that means we cannot have this. We cannot have an irrational number in the denominator of a fraction. So when this happens, we want this number that's bad to go away, quote unquote. And the way we do that is we multiply by the number we want to go away on top and bottom. Essentially, we're effectively multiplying by 1. Right? So we're effectively multiplying by 1, and what that's going to give us is square root of 2 over the square root of 4, or square root of 2 over 2. So our sine of 45 degrees is equal to the square root of 2 over 2. And that's the proportion that we'll always use for a sine ratio of 45 degrees, right? Well, what about these other angles? So if we look at those in the same respect, let me erase, give myself some room again. If we look at those in the same respect, we can plainly see that the sine of 30 degrees, for example, would be 1. So opposite over hypotenuse, so it'd be 1/2. That would be the sine of 30. And what about the sine of 60? Well, the sine of 60, I'm going to go ahead and use another color here. Sine of 60, well, that would be opposite over hypotenuse. So that would be square root of 3 over 2. Okay, so we've got those three. And real quick before we move on, so what if we had the sine of a 0 degree angle? You will see this. The sine of a 0 degree angle is simply 0. Okay, so a little side note there. All right, so now the second ratio, this is called the cosine ratio. Okay, so we're given an angle, but we're not given the opposite leg this time. This time we're given the close leg, or the adjacent leg. Okay, the cosine ratio is equal to the adjacent leg, and adjacent is a fancy way of saying near or next to. It's the ratio of the adjacent leg to the hypotenuse. So, the cosine of a 60 degree angle, right? So we know this is a 30, 60, 90. So this would be 1 square root of 3 to 2. Right, and we're looking at short leg, and we're trying to find the missing hypotenuse. So our cosine of 60 degrees, and well, here, I'm getting ahead of myself. Let's just set it up as a proportion. So short leg to hypotenuse of a 30, 60, 90 is 1 to 2. And 1 is to 2 as 14 is to our missing hypotenuse. Just cross multiply. We're going to get 28 equals C. So this guy is 28. Okay, pretty easy peasy. Same thing over here, given a 45-degree angle. And this guy's 45, so that means this guy is 45. So this is a 1 to 1 to square root of 2. And we're looking at the adjacent leg. And in this case, it doesn't matter which one we pick. To the hypotenuse. It doesn't matter because they're both, it's a 1 to 1, right? So this U is going to be the same over here as well. Anyway, so we've got 1 is to square root of 2 as U is to 6. So again, that's adjacent is to hypotenuse as adjacent is to hypotenuse. Cross multiply, 6 equals square root of 2 times U. Divide by square root of 2 on both sides. Oh, and we get an irrational denominator, which is no bueno. And the way we're going to make that go away is just like I showed you on the previous slide. We're going to multiply by the number we want to go away on top and bottom. That's going to give us 6 square root of 2 over 2. 6 and 2 have a GCF, or greatest common factor, of 2. So that leaves me with 3 square root of 2. And that makes perfect sense, right? Because on the original 1 square root of 2, all you're doing is taking the leg length and multiplying it by the square root of 2 to get your hypotenuse, right? So if I did square root of 3 times the square root of 2 times the square root of 2 again, that would just give me 6, which is what this hypotenuse is. Okay, let's do one more. Then we'll generalize the cosine ratio. Make some room. Actually, let me keep making room. Really? Okay, given a 30-degree angle this time. So that means we have a 1 square root of 3 to 2. And we're given the adjacent leg, and we're trying to find the hypotenuse. Okay, so we're given the adjacent leg. In this case, it's the long leg, square root of 3. And we're trying to find the hypotenuse. So square root of 3 is to 2, as 9 square root of 3 is to our missing hypotenuse, z. Cross multiply, we're going to get z square root of 3 is equal to 18 square root of 3. Divide by square root of 3 on both sides, and z is 18. Okay, so pretty straightforward. So now let's go ahead and generalize the cosine ratio. So cosine, again, cosine is simply adjacent leg over hypotenuse. So the cosine of a 45-degree angle, we say like this, right? And notice how I'm writing the abbreviation with the angle right next to it. That's exactly how you want to be doing it. Same thing over here with sine, right? Anyway, back to cosine. So the cosine of a 45-degree angle is adjacent over hypotenuse. So that would be 1 over the square root of 2. Can't have that though, so we need to rationalize the denominator. Okay, that's what this process is called, if I didn't mention that. So I rationalize the denominator by multiplying by the bad number top and bottom, and that quote-unquote makes it go away. That fixes it. This would be the square root of 2 over the square root of 4, which is 2. So the cosine of 45 degrees is square root of 2 over 2. Okay, if I do the cosine of 30 degrees, that would be equal to the square root of 3 over 2. Again, adjacent over hypotenuse. And if I do the cosine of 60 degrees, again, adjacent over hypotenuse, that would simply be 1/2. Okay, so now cosine's a little bit different. If we have the cosine of a 0-degree angle, the ratio there would be 1. So another little interesting side note there. Okay, so now we're looking at tangent. So tangent's different. Obviously, they all three are different. But tangent doesn't use the hypotenuse at all. Tangent just uses the legs. Okay, and it's always opposite leg over adjacent leg. Okay, so if we're trying to find, so we're given this 60-degree angle, and we can tell that this must be 30, so this is a 30, 60, 90, meaning it's 1 square root of 3 to 2. That means that we have, so we're given the short leg, we're going to use short leg and, and long leg. So that means we're going to say long leg, or opposite leg, is to adjacent leg as opposite leg is to adjacent leg. Cross multiply, 18 square root of 3 equals a times the square root of 3. Divide by square root of 3 on both sides, we get a equals 18. So this missing leg here is 18. Same thing over here. We're given a 45-degree angle. And this is obviously a 1-to-1. Okay, and our leg-to-leg ratio is right there, 1-to-1. So 1 is to 1, as 7 square root of 3 is to our missing x, right? Because we're doing opposite over adjacent. Cross multiply, x equals 7 square root of 3, and that should have been pretty obvious because, you know, this is a 1-to-1. Okay, so let me erase here and give myself some room. Okay, so we're given this 30. So again, we have a 1 square root of 3 to 2, and we're only going to be using the legs, right? Our opposite leg in this case is the short leg, so we're going to do opposite over adjacent is equal to opposite over adjacent, because we're doing tangent. Cross multiply, and we're going to get 12 equals square root of 3 times u. Divide by square root of 3 on both sides, we're going to get 12 over the square root of 3, which is bad. So we want to rationalize. And that's going to give us 12 square root of 3 over 3, which in turn is going to be 4 square root of 3, and that is equal to our missing leg u. Okay, so let's go ahead and generalize tangent really quickly. So tangent, if we have the tangent of a 45-degree angle, that means we are doing opposite over adjacent. So opposite over adjacent is equal to the tangent ratio of a 45-degree angle. And we already know that's simply just 1. So the tangent of 45 degrees is 1. Okay, so what about the tangent of a 60-degree angle? Well, again, you have opposites over adjacent. So that's going to be square root of 3 over 1, which is, of course, just the square root of 3. So tangent of 60 is simply square root of 3. And last but not least, we have tangent of a 30-degree angle. So the tangent ratio of a 30-degree angle is equal to, again, opposite over adjacent. That would be 1 over the square root of 3. But we have to rationalize, so we're going to multiply square root of 3 over square root of 3, and we get square root of 3 over 3. So the tangent ratio for a 30-degree angle is simply square root of 3 over 3. And here we have a table representing everything that we just went over. And notice that I'm calling this the quadrant 1 angles, and we'll get into that later when we start talking about the unit circle. But for now, this table is super important, and you need to know it by heart. And I forgot to mention the tangent of a 0-degree angle is going to be 0. And we also see here, we have the sine, cosine, and tangent for 90-degree angles. So the sine of a 90-degree angle is 1, the cosine of a 90-degree angle is 0, the tangent of a 90-degree angle is quote-unquote undefined. Okay, so really quick, I was about to call this video quits, but forgot about EQ6. So what does SOHCAHTOA mean? So stands for sine is opposite over hypotenuse. What about the CAH in SOHCAHTOA? Well, obviously the C is cosine. The A is adjacent, and the H is hypotenuse, because cosine is the ratio of adjacent leg over hypotenuse. And I think you get the idea of how this works now. So what do you think tangent means? Well, tangent, or TOA, stands for tangent is opposite over adjacent. And there you have it, SOHCAHTOA. This is going to help you remember your trig ratios. If you can remember these little acronyms, SO has to do with sine, right? Sine is opposite over hypotenuse. CA has to do with cosine. Cosine is adjacent over hypotenuse. And TOA has to do with tangent. Tangent is opposite over adjacent. Okay, so like always, kiddos, if you have any questions, let me know. Obviously, this is one of the most important, if not the most important thing we're going to learn in this class. So ask a lot of questions in class or through email or just whenever. Okay, you really need to know this. And obviously, you see down here, we've got another test coming up. Okay, our Unit 2 Test 2 review will also be today. Okay, so make sure you get started on that. And again, ask a crap ton of questions. And that's it for this video, children. Goodbye.